Today I'll begin with the basics of inorganic chemistry. Okay, it will be basics. Maybe some of you will feel like this much of basic is too basic. What are the principal quantum numbers, or what are the principles for the entry of electron into a given set of orbitals? But you will find some difference. Whatever you have learned till now and what you are going to learn today, it will be little bit different. Okay, so today and in the next class it will be like some basics which will be useful for the complete inorganic chemistry. And even when I go to spectroscopy, in spectroscopy there will be a few basics. Again, I will not be taking there. So these classes will be the basics of little bit spectroscopy also, right? So put the heading as basics in inorganic chemistry. You have learned all these things right from your school ages. Suppose just let me begin with a substance. If I break down the substance, what do we get from the substance? I just take a substance, maybe I have taken this pen, I am just breaking it down. So what are the basic entities that I get? Can I call it as molecules from substance? Suppose if I get molecules, I break down these molecules. From these molecules, what do we get? Atoms. Okay, so atoms are the components that make up these molecules. Can I break these atoms? Is atom a fundamental particle? Can I call atom as a fundamental particle? It is an entity which will participate in a chemical reaction. That we know. But according to Dalton, what does atom mean? According to Dalton, what does atom mean? It has come from a word, tomos. Tomos means divisible, or we call sliceable. Can we divide it? Can we slice it or not? That is what we call it as tomos. Means generally whatever is negative, that is defined by suppose in our language, if I say satyam, that which is truth. If I say asatyam, that which is not truth. It means wherever you get generally it is like negative, dharma, adharma. Likewise, tomos is sliceable, and if you get a tomos, it means not sliceable or not divisible. So A means not or un. So atom is basically undivisible or unsliceable. That is the definition given by Dalton. So at that time they thought atom is the ending. There can be nothing within the atom, but later studies have proved that atom has got some fundamental particles within it. So if I get deeper into atom, what do we get? What does an atom contain means? Mainly atom contains nucleus and electrons. Nucleus and electrons. Okay, up till this point we are aware of. Electrons are called as fundamental particles. Fundamental particles means I cannot further divide them. That is the end. That can build up something else, but it cannot be built up by something else. So electron is called as a fundamental particle. Nothing else will build up an electron. Electron will build up something else. Okay, so electron is a fundamental particle. Is nucleus a fundamental particle? Can you call it as a fundamental particle? No. Nucleus is further composed of various subatomic particles, of which two are very important for us. One we call it as proton. The other we call it as neutron. So now can I call them as fundamental particles? Proton, neutron and electron. So if I ask you a simple question, how many fundamental particles are there that build up an atom? 3. What are they? Proton, neutron and an electron. Can I divide an electron, or is electron made up of something else? Is electron made up of something else? No, it is a fundamental particle. But proton and neutron are further made up of something else. So they are not called to be as fundamental particles. I cannot call proton, I cannot call neutron as a fundamental particle, because every proton, just suppose if I am considering this as a proton, I consider this as a neutron. Within this proton, each proton or each neutron is further made up of 3 quarks. We call them as quarks. So can I break down a proton? Can I break down a neutron? The answer is yes. A proton can be broken down, a neutron can be broken down. It is further made up of 3 quarks. But can I further break down a quark? Till now the answer is no, because the quark is called as a fundamental particle. It means quark is not made up of something else, but it can make up some other structures. So quarks will make up a proton, quarks will make up neutron, protons and neutrons make up nucleus, nucleus along with electron make up atom, atoms make up molecules and substances and so on. So this is the basic classification. Okay. So what are the fundamental particles? It is not proton, neutron and electron. It is quarks and electrons. Okay. So we have 2 fundamental particles, quarks and electrons. I said every proton contains 3 quarks. Every neutron also contains 3 quarks. There are different types of quarks. It is about physics concept. We don't want it. But just for our information purpose, suppose if I am taking these quarks, 2 important quarks are up quarks and down quarks. Up quarks and down quarks, each of which will have some charge. Suppose if I am taking up quark will have plus 2/3 charge, down quark will have minus 1/3 charge. So what is the charge of an electron, or what is the charge of a proton, what is the charge of a neutron? That depends upon this. Electron anyway, it is negatively charged, forget about it. But what is the charge of a proton? You say positively charged. Generally you assign it to be +1. What is the charge of a neutron? There is no charge, it is neutral. Why is it neutral? Let us understand. Proton is made up of 3 quarks. There are 2 up quarks and 1 down quark. So these 2 up quarks, these 2 are up quark, this is a down quark. Whereas in a neutron there will be 2 down quarks, 1 up quark. Okay, proton is made up of 2 up quarks, 1 down. Neutron is made up of 2 down quarks and 1 up quark. So here I have 2 up quarks. What is the charge of each up quark? Plus 2/3. So I take plus 2/3, plus 2/3, down quark minus 1/3. So now sum them up. Plus 2/3 minus 1/3. How much will it be? Plus 1. Okay. So what is the charge of proton? You say positively charged. Generally you assign plus 1. Okay. Arbitrary value. For neutron, 2 down quarks, minus 1/3, minus 1/3, plus 2/3. How does it make up? Minus 1/3 and plus 2/3. Minus 1/3 and plus 2/3. Minus 1/3 is minus 2/3. Minus 2/3 and plus 2/3 are 0. So altogether it is making up 0. Then you say, what is the charge of neutron? Neutrally charged. It is 0. How did you get that? From the charges of the quarks. Here I am speaking about the charges of the quarks, but not the spin of a quark. I am not speaking about a spin. Okay, now let us come to the conclusion. Substances are made up of molecules. Molecules are made up of atoms. Atoms are made up of nucleus and electrons. Electrons are the fundamental particles. Nucleus are further made up of protons and neutrons. Protons and neutrons are further made up of quarks. Quarks, there are up quarks and down quark. Up quark plus 2/3, down quark minus 1/3. The charges will give you plus 1 to the proton and a neutral charge or 0 for the neutron. All this is the basic makeup of a atom. Okay, we are not speaking about spin till now. Electron has a spin. How much is the spin of an electron? What is the spin of an electron? Any electron that you take, what is the spin? 1/2. Okay, so before going into spin, you just note down these points. I will not give you full points, just write down this classification, that is enough. In the basics in inorganic chemistry, note down these substances, molecules and so on. This is just a first class, so you should be knowing all the basics. What are the principles for the electron entry into a given set of orbitals? What are the various quantum numbers, shapes of orbitals? What is spin multiplicity? These things will help you in spectroscopy also. When you go to some interviews, there will be basic questions like, why is the spin of electron 1/2? Or how is the spin of electron 1/2? If I give you an orbital, how many electrons can you put into an orbital? I've given you an orbital. Into that orbital, how many electrons can you put? How many? One orbital. How many does it take? 2 electrons. Let it be a p orbital, let it be an s orbital. Number of p orbitals might vary, but every orbital will take up only 2 electrons. There was an interview question. The interview question is, why an orbital can take up only 2 electrons? That was the question. Can anyone answer it? When you go to IASC, when you go to IITs, there will be a few scientists who will be asking you with the basics also. They just want to know how much subject do you have. It is just like not the book subject, but what is the basic knowledge that we have. So they will be testing it, and this was one of the questions. Let me just give you 1s orbital. Just imagine the size of 1s orbital is this much. 2s will be large. 3s still larger. 4s, 5s. 5s is still large. But if I take an electron, does the size of electron increase? Consider electron as a particle. It has wave dual nature, wave as well as particle nature. But just imagine electron as a particle. Does the size of electron increase or decrease as a particle? Should it increase or should it decrease? No, it will remain same. It has to remain the same. Every electron should remain the same, right? But I am choosing 1s. I am choosing 5s. 5s has a lot of space. Then in that such a big space, why should I put only 2 electrons? Why can't I put third electron? Because there is lot of space, maybe if it is 1s orbital, both electrons are like charged, they fight with one another because of repulsions having same charge. So place is very less, I am unable to accommodate third electron into that. But maybe if I choose 5s orbital, or maybe 3d, 4d, 5d, I am choosing 5d orbital, which is large. Why can't I accommodate more than 2 electrons? Space is available. Then how do you explain it logically? Okay, we'll see it. Is it done? Write down just a simple point. Atoms are made up of two fundamental particles. Atoms are made up of two fundamental particles. These are electrons. These are electrons and quarks. These are electrons and quarks. Quarks have charge. Quarks have charge and also spin. Right. What is the charge of electron? Spin. Okay, charge we have completed. First let us come to spin. It is negatively charged, proton is positively charged, neutron is neutrally charged or 0. We assign 0 for it. Let us come to the spin. What is the spin of electron? Is it plus 1 by 2 or minus 1 by 2? Why not plus 1 by 2? We are not speaking about charge. We are speaking about spin. 1 by 2. The charge of an electron is 1 by 2. Does neutron have any spin? I am not asking about charge. Does neutron have spin? Will neutron spin? If I give you an electron will not remain like this. Electron always spins. It is just like your earth. Earth will not remain static. Earth always spins. Does neutron spin? No. Does proton spin? No. But which particle will spin? Only electron will spin. But neutron will also spin. Proton will also spin. They can spin. If I give you an individual neutron, it will spin. If I give you an individual proton, it will spin. No particle in this universe will be static. They always spin. Definitely. Okay. So I have given you a proton. I am asking you what is the spin of a proton. The answer is 1 by 2. What is the spin of neutron? 1 by 2. What is the spin of electron? 1 by 2. In which direction is it spinning will give you a sign. It is not a charge. It is a sign. When I give you plus, when I give you minus, if you consider it as charge, that is different. If I give you plus or minus 1 by 2, whatever plus or minus that is there, it is not charge. It is sign. That is a sign indicating if it is rotating clockwise direction plus, if it is rotating counterclockwise direction or anti-clockwise direction, you give minus. So here plus or minus is not charge. It is indicating spin. Plus 1, minus 1 for proton or electron, that is indicating charge. Okay. So what is the spin of an electron means 1 by 2. If it is spinning clockwise direction plus 1 by 2. If it is spinning counterclockwise, it is minus 1 by 2. Proton also plus or minus 1 by 2. Neutron also plus or minus 1 by 2. Every particle has a spin. That is the conclusion. Quarks will also have spin. The spin of the quarks will give you the spin of a proton. I said 2 up quarks, 1 down quark. So if 2 up quarks has 1 spin, the down quark has other spin. Overall it will be 1 by 2. Overall it will be 1 by 2. And for electron, 1 by 2. Okay, I'll ask you a simple question. Everyone is aware of NMR? NMR, nuclear magnetic resonance spectroscopy, which you might have studied. In your NMR spectroscopy, what is the most studied nuclei? What is the most studied NMR? Not C13, H1. You call it as PNMR. PNMR means proton NMR. When I call it as a proton NMR, generally what is a proton? In general, for inorganic chemistry point of view, whenever I say a proton, or maybe your organic chemistry point of view, if I say proton, it is H plus, right? Proton is positively charged, we say H plus. But for NMR spectroscopy point of view, whenever I say proton NMR, don't take it as H plus. It is simply H. Okay, so I call it as PNMR or H1 NMR. Which one is right? H1 or H1? This is right. Okay, this is a older version where you write to the right superscript. Now you have to write it as left superscript. So H1 NMR, why do you study H1 NMR? What is NMR actually? Nuclear magnetic resonance spectroscopy, where a nucleus should spin. Every nuclei, suppose it has a spin, then I give radio waves in the presence of magnetic field. Whenever there is a matching of resonance, whenever there is a resonance, matching of frequency, then this spin will be reversed. So in the ground state, if it is spinning clockwise direction, in the excited state it will be spinning counterclockwise direction. But that nucleus has to have a spin. Nucleus should have spin. Okay. Now my question is, where did the spin come from? Where did the spin come from for a proton or for a hydrogen? If I take a hydrogen, what is the atomic number of hydrogen? What is the mass number? How many number of neutrons? Mass number minus atomic number, 1 minus 1. Neutrons, we write it as right subscript. So this represents atomic mass, or I write it as mass number. This is atomic number, these are neutrons. There is no neutron. There is an electron, but electron will not participate in your NMR spectroscopy. There is a shielding or deshielding, that is a different thing. But how many protons are there? Only one proton. So the nucleus of hydrogen, if I take a nucleus, this nucleus has only one proton. And that one proton has to spin. If it does not spin, where is NMR? If I give you 6C12, can you record NMR? No. If I give you 6C13, why? 6C12 also has protons, it has neutrons, electrons, but why not? Why can't you record for 6C12? Why only for 6C13? It is nuclei? Inert. Why is it inactive? That is my question. Okay, again, let us come to the basics. So what is the spin of proton? We say 1 by 2. So proton will have a spin. The spin of a proton is 1 by 2. Hydrogen has how many protons? Only one proton. That one proton will have a spin of 1 by 2. So for any proton spectroscopy, proton NMR spectroscopy, what is the spin I value of hydrogen? You write 1 by 2. I value of hydrogen is 1 by 2. How did you get that 1 by 2? It is the spin of that proton, which is 1 by 2. Or if I take 6C12, how many neutrons are there? 12 minus 6, 6 neutrons are there. Every proton or every neutron which is present, they pair up. Just like if I give you one electron, will go and sit in some orbital. If I give you two electrons, they may pair up. They may or may not pair up, depends. They may pair up. If I give you one proton, it will just go and sit singly. If I give you 2 protons or 2 neutrons or a proton or a neutron, they may pair up, they may not pair up. That depends. It is just like some students have come. He is sitting singly. You are sitting singly. The others, they got paired up. You got paired up. What is the reason? No reason for that. It is a choice. You may sit singly or you may sit together. In a similar way, if I give you a proton, if I give you a neutron, this proton and neutron could be unpaired, or this proton and neutron can get paired up. They may get paired up. Just as electrons pair in an orbital, the neutrons and protons can also pair up. Now when they pair up, how many protons are there? 6 protons. How many neutrons are there? 6. This is even number. This is also even number. So even number, all of them will pair up. When every proton and neutron is pairing up, how many unpaired protons are there? 0. How many unpaired neutrons? 0. So there is no net spin. Net spin is 0. So I cannot record NMR for 6C12. You say it is nuclear NMR inactive because the net spin is 0. I am calling about net spin. Individually 6 protons have spin, 6 neutrons also have spin, but the overall spin is becoming 0. If I take 6C13, then I have got 7 neutrons. 6 protons, 6 neutrons pair up. How many excess neutrons are left out? 1. That 1 neutron will have spin of 1 by 2. So what is the spin of 6C13 I value? You say 1 by 2. How did you get 1 by 2? It is the spin of that unpaired neutron. It is the spin of that unpaired proton. Okay? So let it be a proton or a neutron or an electron, they definitely have spin. Let me give you one last example. If I give you deuterium, what is the spin of deuterium? 1. How did you get 1? These things are difficult to explain. Electron configuration is easy to explain. Nuclear configuration is difficult to explain because you don't know how the neutrons and protons pair up. When there are neutrons, neutrons may pair up. When there are protons, protons may pair up. Or neutrons and protons may pair up. So it is very, very difficult. And when you go to subatomic level, proton and neutron, they convert into one another. In nuclear chemistry, you will be knowing it. Every proton is not always a proton. Every neutron is not always a neutron. Just proton and neutron are interconvertible. By emitting some particles, they are interconvertible. Okay? So here I have given you 1H2. How many protons are there? 1. How many neutrons are there? 1. Each of them will not pair up. In this case, proton is unpaired. Neutron is also unpaired. What is the spin of that proton? 1 by 2. There is one proton, 1 by 2. What is the spin of that neutron? 1 by 2. 1 by 2 plus 1 by 2 is 1. So what is the spin of deuterium means? 1. That is how you get the nuclear spins of different nuclei. You take proton, 1 by 2, F19, 1 by 2, P31, 1 by 2, C13, 1 by 2. All these are common nuclei. In your exam also, most commonly they will be asking you proton, 6C13, and then they will be asking you F19, P31. These are the 4 important nuclei, and for all of them the spin is 1 by 2. Okay? Suppose I ask you F19. Now you tell me what could be the spin. Spin is 1 by 2 I said. For proton P31 NMR it is 1 by 2. F19 is 1 by 2, proton is 1 by 2, C13 is 1 by 2. How could it be 1 by 2? Now you just get the answer. 9 protons, 10 neutrons. So 9 protons, 9 neutrons pairing up, 1 neutron is in excess, 1 by 2. 15 protons, 16 neutrons, 15 and 15 getting paired up, 1 neutron is unpaired, spin is 1 by 2. So the nuclear spin of phosphorus is 1 by 2, fluorine 1 by 2, H1 is 1 by 2, C13 is also 1 by 2. Understood now? When we discuss Mossbar spectroscopy, in Mossbar spectroscopy, ground state iron spin will be 1 by 2. But when it goes to excited state, it will become 3 by 2. Further excited state 5 by 2. Further excited state 7 by 2. The spins will increase because the neutrons or protons, they get unpaired. As the energy is increasing, they get unpaired, and the spin will also increase. Either it will be integral increase or half integral increase. Integral increase means, suppose if the spin is 1 in the ground state, the excited state it can become 2, 3, 4. This is called as integral increase. This is called as half integral increase. Spin is half integral, half integer. Half integer means 1 by 2, 3 by 2, 5 by 2, 7 by 2. This is called as half integral spins. These are called as integral spins. 1, 2, 3, 4 and so on are called as integral spins. Okay. So now let us conclude. Every subatomic particle have some spin. Quarks have spin. Quarks make up protons or neutrons, therefore they also have spin. So finally you note down this table: particle, proton, neutron and electron, spin 1 by 2, 1 by 2, 1 by 2. Don't put plus or minus. Just note down the spin. First note down this table. Don't write all these things. One H2 can also be written as 1D2, D for deuterium. I represents nuclear spin. Can I rub this table? Here I am giving it as sign. It is not charge, just a sign. Suppose if I give you an orbital, p orbital I will give you. In p orbital, how many lobes are there? 2 lobes. If I give you a p orbital, there will be 2 lobes. What is the sign present here? So this is not charge. This is sign. there is a difference. It means just imagine a wave. The wave is progressing. If the wave is above, I give plus. If it is coming below, I give minus. That is called as a sign, not a charge. Plus, minus, plus, minus. Integral spins, all integers 1, 2, 3, 4 and so on. Half integral spins. The normal terminology we use is anti-clockwise, but in standard textbooks they use counterclockwise. Because once you enter into your research field, you will be interacting with different scientists coming from different universities. Maybe you are presenting a paper. So while presenting an oral presentation or poster presentation or a paper presentation, the language that you use should be at a higher level. So instead of say wherever you get anti-clockwise, use the word counterclockwise. So you have to use terminology in a different way. Finished? Then you put a small subheading. Quantum numbers. Or before going into quantum numbers, first of all we'll discuss, first we'll go for quantum numbers, then the rules guiding the electron entry. What are these quantum numbers? How do you define them? Quantum numbers are energy levels. Simply they are energy levels. Quantum numbers are nothing but energy levels. Suppose you have come to this building. Okay. So if I ask you your address, presently somebody is asking you where are you present. Then how do you define them? I am present in so and so building. In that building, where are you present? I am present in so and so floor. In that floor, in which room are you? I am in so and so room. In that room, in which bench are you sitting? I am in the so and so bench. So this is your final address. Likewise, if I give you an electron and I'll ask an electron, where is your address? There are 10 electrons. Each electron will have a different address. I am asking their address. That address is through quantum numbers. So where is it present? Maybe it is present in the first shell. In that shell, where is it present? In some subshell. In that subshell, it is present in some orbital. In some orbital, it is present as upspin, or it could be present as a downspin. That is the address. So that address is given by these quantum numbers. How many quantum numbers are there basically? 4. Just let us write down. This is like a brush up only. We are aware, but just let us write. First one we call it as principal quantum number. Second one, azimuthal quantum number. You can simultaneously write down because these are just basics. You also call it as orbital quantum number, azimuthal quantum number or orbital quantum number. Third one, magnetic quantum number. Fourth one, spin quantum number. So altogether 4 different quantum numbers. Every time I ask in every batch, why do we write NO? Yeah, NO is number, but why do you write NO? How does it abbreviate number? Because number is NUMBER. Why do you write NO? No, not prefix. I used to watch lot of comedy movies. There is one comedy movie in Telugu, a very old one. So there a person goes for an interview. He tries that he doesn't get selected, because if he gets selected he has to do a job. So very sincerely he tries that he not get selected. But his father will be giving some recommendation to that interviewer, you have to select them. Then the interviewer says, we'll ask very simple questions. He has to answer those questions, only then we can take, because this is company norm. We'll ask so basic questions, he will definitely answer. But this person tries to see that he will not get selected. So there a question is asked. They'll ask, what is the spelling of coffee? You just say the spelling of coffee, we'll select you. Then he says it is very difficult, spelling of coffee. And finally he says, he gives the spelling. How does it pronounce? Coffee. Then the interviewer, he says Kauphy. Then the interviewer goes mad. For the first time in my life, I have heard coffee spelling where every alphabet is not matching. Because what is the spelling of coffee? No alphabet is matching. But pronunciation is same, coffee. This is also coffee. So here I have written number. Where is NO coming from? English is a copy language. Numero. Latin, Greek, they call it as numero. Numero uno. Numero uno means number 1. Numero uno, number 1. So numero means number. Numero, first and last. That is where you get NO from. Generally we abbreviate NO, we put a dot, it means it is an abbreviation. But that has come from numero. But anyway, what the idea does principal quantum number give about? Just one word only. We are not going in depth. We are aware of all these things. What idea does it give about? It gives an idea about shells. So I am writing idea about shells. Azimuthal quantum number, subshells or orbitals, but subshells contain orbitals. Okay. Next, magnetic quantum number, orientation of orbitals, and spin quantum number, spin. All this is with respect to an electron, all these quantum numbers. So we define it as a spin of an electron. Principal quantum number, okay, it is indicated by N, L, this one. This is indicated by N, L. We call it as M sub L, M sub S. Sub L means subscript. Sub S means subscript. So you should not write ML like this. You have to write it like L should be subscript. So we define it as M sub L, M sub S. This becomes ML unit. Gives an idea about shells, subshells, orientation of orbitals and spin of an electron. And all these quantum numbers are energy levels. They have specified energy. When I jump from first floor to ground floor, where am I starting from? First floor. Where do I end up? Ground floor. But you cannot define me, sir is in 0.25 floor, 0.26 floor. No. Either I will be present in the ground floor or I will be present in the first floor. That is how you have to understand. So all these are like quantized energy levels. There is no in between. There is no in between. So you call them as quantized energy levels. Every quantum number, every energy level is quantized. Can you give me some shells? Some shells? K, L, M, N. Subshells? S, P, D. F is also there, but F we generally omit because it is complex. Orientation of orbitals. In the orientation we have various ML values. Suppose if I take P orbital, Px, Py, Pz. For D there are 5, I am not writing. And spin of an electron, it could be clockwise or counterclockwise, plus or minus 1 by 2. I will also write SPDF. When N value is 1, you call it as K shell. And one more small or silly question. Why not ABCD? Why not ABCD? Why KLMN? Any answer? all simple doubts or simple questions, because some of you may go into teaching field, some of you will choose IIT or NEET coaching centers. The students will be like they will not be like very matured, they always want to pull the leg of the teacher. So some of them will ask, sir, why KLMN, why not ABCD? Alphabets begin from ABCD, why did they choose in between KLMN, not even the last alphabets? Completed. K represents Greek and Latin words. K represents kernel, core, the most central part, the first one. So that is represented by kernel or K, core. So from that kernel or core they have taken the alphabet K. After K they went on with the alphabetical order K, L, M, N, O, P and so on. So that is how K, L, M, N has come. Otherwise they could have taken ABCD simply. Okay, I am satisfied with this explanation. But how SPDF? Not even alphabetical order. At least here it is alphabetical order, starting from K, L, M, N, alphabetical order. That is fine. But how SPDF? Completely random. How will you explain? In the atomic spectra, the lines that are emitted, they have different shapes coming from the orbitals. So based on those shapes, SPDF has been assigned. Suppose if the line or if the peak is sharp, that sharp, the first alphabet is given for S orbital. Or if it is a principal peak, from that principal peak P, diffused peak D, fundamental peak F. So all these are peaks coming in the atomic spectra. From there we got, remember, small SPDF, not capital. If you write capital up to your intermediate level or degree level, that is fine. But at PG level you should not write in capitals. When I write SPDF in capitals, this indicate term symbols. When we go to electronic spectroscopy term symbols, there you will be getting all these capitals. So now you have to be very careful while writing our small or capital. Till this point it is fine, but now you have to be very specific. Completed? ml values, 2l plus 1 values. So for s orbital, how many l values we got? 2 into l plus 1. S value is 0. L value for s is 0, 1, 2. So how many 2 into l plus 1? 2 into 0 plus 1 is 1. That 1 is s. For p, it is 3. So first of all, I will put 2 into 0 plus 1 is 1. Okay, I am just giving 1. For p, it is 3. What are these 3? Starting from plus L up to minus L. Starting from plus L up to minus L. Plus L means how much is L value? Here it is 0, here it is 1, here it is 2. So plus L up to minus L, it means plus 1 with a difference of 1, because every energy level is quantized. I cannot take 1, 1.2, 1.3. I have to take 1, 0, minus 1. With a difference of 1, we have to choose. Plus L up to minus L. So plus L means I write plus 1, 0, minus 1. There is one value, but what is that one value? 0. Hope you are understanding it. Okay, I am giving plus L up to minus L. So this one number is ml values. Next one 0 is, what is that ml value? Is 0. 3 ml values. What are those 3 values? Plus 1, 0, minus 1. And for D, 2 into L plus 1. So how many L values? How many ml values? 5. Altogether you will get 5 values. 2 into 2 plus 1, 5. What are those 5 values? Plus 2 plus 1, 0, minus 1, minus 2. Now for these, there are orbitals. So suppose if I take plus 1, this is s orbital. This is px. If this is px, this will be py. If I take this as px, this has to be py. Or if I take this as py, this has to be pz. Sorry, px. If plus 1 is py, if this is py px, this will be px py. Okay, but 0 will be pz. Remember, wherever you are giving 0, that has to be pz. Plus or minus 1, if you write px or py, it is up to you, no problem. If you write this as px, this should be py. If you write this as py, this should be px. Okay, then for 0, dz square only should be written. Don't write any other orbital for 0. It has to be dz square. For plus 1, I may take dxz, then this will be dyz. If I take this as dxz, this will be dyz. Or if I take this as dyz, then this should be dxz. For plus 2, if I take dx square minus y square, this must be dxy. Or if I take this as dxy, this should be dx square minus y square. But you cannot take xz and yz for minus 2 or plus 2. Remember. Why is this table important? You will come to know. You can just note it. This 5 is 2l plus 1 values. If you are confusing, you just write 2l plus 1 values. and this is plus L up to minus L. Plus L is 0, minus L is also 0, therefore 0. Finished? One beautiful relation will take from this table, which will be very useful for your basic understanding of chemical bonding. Right. What is this ml value? 0, 0 and 0. Okay, so whatever ml values where you got 0, I'm just taking them. ml value wherever I got 0. Which orbitals do I have? S, Pz, dz square. Okay, later I'll choose plus 1, I'll choose minus 1. I'm choosing plus or minus 1. What are the orbitals I have? Px, Py, dxz, dyz. Later I am choosing plus 2 or minus 2. Dx square minus y square dxy. What is the importance? Any orbital which has an ml value of 0, remember this point, that can only form a sigma bond. I cannot form a pi bond with s orbital, pz orbital or dz square orbital. Only sigma bond can be formed. And with plus or minus 1, px, py, dxz or dyz, pi bond will be formed. pi bond can be formed only by the combination of these orbitals, but nothing else. And finally, dx square minus y square and dxy will give you delta bond, not any other orbital. Okay, that is the beautiful relation coming from this table. So wherever the values, angular momentum values are 0, they form sigma bond. That is how you have to understand. Any orbital which has angular momentum of 0 will form sigma. Any orbital which has angular momentum value of plus or minus 1 can form pi. Plus or minus 2 can form delta. Okay, note down this table. Symmetry has to match. Symmetry has to match means all of these will have symmetry to form pi bond, but which orbitals can combine px with another px, py with another py, but not px with py. Okay, so px can combine with a px, py with a py, dxz with dxz, dyz with dyz. But you also look at the common factor, which is x coordinate. It means a px can combine with a dxz for pi bond formation. It is possible because there is a common coordinate. Py can combine with dyz. All these are combinations in chemical bonding. So px px, py py, px with dxz, py with dyz. All of them can give you pi bond. Dx square minus y square with another dx square minus y square, dxy with another dxy. That will give you delta bond. This is phi bond. Sigma, pi, delta, phi. We have compounds up till sextuple bond also. In the organometallic chemistry, there is a chromium example where between two metals you have 6 bonds. That is the maximum possible number of bonds. In your organic chemistry, you will be looking only up to triple bond, 1 sigma and 2 pi bonds. But in the inorganic chemistry, we can even go to sextuple bond. But for our discussion in the organometallic chemistry and clusters, we'll go up to quadruple bond. So you have to discuss about delta bond also. Which orbital could be involved here? Because for delta, pi, sigma, all d orbitals are completed, p orbitals are completed, s orbitals are completed. So for phi bond, f orbital will involve. Okay, f orbital involvement will give you phi bond, phi bond. Finished. Write a small subheading. Principles or rules. Principles or rules guiding the electron entry. Principles or rules guiding the electron entry. First principle or rule of Bow. Greek and Latin words. Of Bow. Bow means building. Of means up, building up. So the name itself will tell you, if I give you a few energy levels, different energy levels. If this is the ground state, first excited, second excited energy level, where do the electron fill up? Ground, building up. So if I start constructing a building, where do I begin from? Maybe SLR, ground, then I will go to 1, 2, 3, 4, 5, but not from 5, 4, 3, 2, 1. So it is a very simple rule which says the lowest energy levels are filled up first, followed by the higher energy levels. Simple rule. Just note down one point. One line about the rule, of Bow rule or principle. Lowest energy levels are filled up first. Lowest energy levels are filled up first. Lowest energy levels are filled up first. That is first rule. No more explanation, it is a very simple rule. What is the second principle or rule? Pauli's, or shall we go for Hund's rule? Some abbreviate it as Hund, or you can also call it as Hund. Both different types of pronunciation. Hund's rule. What is the full rule? Hund's rule. It is not just Hund's rule. How do you pronounce it totally? It is Hund's rule of maximum multiplicity. So Hund's rule is not simply Hund's rule of maximum multiplicity. How do you explain the rule? How do you explain the rule, Hund's rule? if I take a set of p orbitals, I am giving 2 electrons. How can those 2 electrons arrange? First or second? Which is preferred? So how do you define the rule? Hund's rule of maximum multiplicity say, when a degenerate set of orbitals are provided, electrons fill singly first. Pairing occur when all the orbitals are singly occupied. This is the definition we have studied till these years. But that definition is not at a higher level. At higher level, what is the definition? Electron filling chooses the maximum multiplicity state. Okay, a state of maximum multiplicity is always preferred. So when I say multiplicity, there is a small formula for electron spin multiplicity. Electron spin multiplicity. Capital S indicates total spin, and electron spin multiplicity is given by 2s plus 1. It is given by 2s plus 1. What is the spin of each electron? Spin of each electron is 1 by 2 if it is up spin, plus 1 by 2 if it is down spin, minus 1 by 2. Okay, up spin is plus 1 by 2, down spin is minus 1 by 2. I am taking the total spin. What is the total spin for this? Then I take the total spin. S is equal to plus half and minus half. So how much does it become? 0. What is the total spin? Plus half plus half. That becomes 1. Now here I am giving the spin multiplicity. 2 into 0 plus 1. Here it is 2 into 1 plus 1. 1 means singlet. Multiplicity is always ending with lets. Singlet, doublet, triplet, quartet, quintet, and so on. So what is the Hund's rule of maximum multiplicity? Any state having a higher spin multiplicity is always preferred. That is actual rule of Hund's. But at lower level, how do we define? For a given set of degenerate orbitals, electrons spin singly first. Pairing occurs when all the degenerate orbitals are singly occupied. Now forget about that definition. Okay, just write down this definition. For a given energy level, comma, a state with maximum spin multiplicity, a state with maximum spin multiplicity is always preferred. A state with maximum spin multiplicity is always preferred. Then you note down this example. See here, I am using the term preferred. What do you mean by it? It is choosing. Preferred means it is like choosing. You like coffee, you like tea, you come to my house or you come to my home, I'll offer you coffee and tea. Which one will you choose? Your choice. You may choose coffee, you may choose tea. So it is a preference. You are just giving a preference there. This is also preference. Suppose if I use more energy, then this state is also possible. I am forcing the 2 electrons against electron-electron repulsions, then 2 electrons can be put in a single orbital also. Therefore we call it as preferred. Okay, so why we use each term also is very, very important. He did not say that is only found. He said it is preferred. Can spin multiplicity be half integral? Here you got integral value 1, 3. Can it be half integral? Yes or no? No, impossible. Spin multiplicity cannot be a half integer. It has to be an integer only. Suppose if I give you only one electron spin is 1 by 2. Then I take 2s plus 1. 2 into half plus 1. I am getting a doublet state. So whether I take single electron 1 by 2 or you take 3 by 2, 5 by 2, integral spin, whatever it could be, spin multiplicity will not be half integer. Remember that point. Spin multiplicity cannot be half integer. Spin multiplicity is always an integer. These things will come in your spectroscopy. Peaks, how does they split? Singlet, doublet, triplet, quartet, quintet or pentet, sextet, septet, octet, nonet, decet. In your NMR you can even see sextet, septet signals also in the multiplicities. This part is completed. For 5, either you use pentet or quintet. It is the one and the same. Shall we go for the last principle? Third one. Third one is Pauli's exclusion principle. What do you mean by it? Or how do you define? How do you define Pauli's exclusion principle? Definition, simple definition. The definition given by Pauli is no two identical fermions. Electron is a fermion. So let me use word electron, which is a fermion. No two identical fermions will occupy the same quantum position. Okay? So no two electrons can have the same quantum state, or they cannot occupy a same quantum position. That is the actual definition of Pauli's exclusion principle, or each electron will exclude another electron. They don't include, but it will exclude. Pauli's exclusion principle, or to put it simply, no two electrons will have all the four quantum numbers the same. This is what we have studied. No two electrons will have all the four quantum numbers the same. But in the actual terminology, you have to call it as no two identical electrons will occupy the same quantum position. Okay? You have come into this building, you have come into this second floor, you have come into this room. You are occupying a bench. Can any one of you occupy the same space? If one is sitting here, the other has to sit there. Can you occupy the same space? Absolutely not. You can exchange, but you cannot occupy a same space. Electrons also does the same. No two electrons can have same quantum position. You have to call it as quantum position. Write down the definition. No two identical particles. Those identical particles could be electrons or something else. No two identical particles, in bracket electrons. No two identical particles can occupy the same quantum position. Can occupy the same quantum position. Tell me these values. What is the, I'll take this as, this is also 2px, 2pz, 2py. Right. So what is n value for this A electron? This is B electron. What is n value? It is present in second shell. So for A electron the n value is 2, for B electron also the n value is 2. For A electron what is the L value? 1, because it is present in p orbital. For p orbital L value is 1. For second electron B also it is 1. What is the ML value? Plus 1, 0, minus 1. So where is the first electron present? In an ML value of plus 1. Second electron, it is also present in ML value of plus 1. What is the spin of first electron? Plus 1 by 2, because it is up spin. What is the spin of second electron? Now these two electrons have all the quantum numbers same. It is invalid. Okay? At least they have to exclude by one quantum number. Minimum is one quantum number. So let us check here. 2 electrons, same n value. 2 electrons, same L value. 2 electrons, same ML value. But first electron has plus 1 by 2. Second electron has minus 1 by 2. So this is a valid situation. This is invalid. So simple. Okay, that is how you can explain Pauli's exclusion principle. 2 electrons exclude one another. By at least one quantum number. That is another definition. 2 electrons exclude one another at least by one quantum number. So that one quantum number could be ms, it could be ml. If I put one electron here, if I put one electron here with same spin, is it allowed? If I put the electrons like this, is it allowed? Yes, because both have same spin, both have same n value, both have same L value, but ml value is different. It is allowed. At least one quantum number has to change. Note it. Mutual exclusion means, do you have idea? Exclusion means when you go to IR and Raman spectroscopy in symmetry and group theory, there will be a statement, principle of mutual exclusion. Principle of mutual exclusion means there are a few point groups where if you get a peak in IR, you will not get it in Raman. If you get it in Raman, you will not get it in IR. Both mutually exclude one another. Exclude means if this is present, that will not be. The classical example that I give is, you go to an Adidas showroom, you ask for Reebok shoe. Will they give? Will they give? You went for an Adidas, but you are asking Reebok. He'll say Reebok is not available. This is exclusive showroom, not inclusive. It is Adidas exclusive showroom. So now you got an idea about the 4 quantum numbers, 3 guidelines for an electron entry, and lastly we'll go to the shapes of the orbitals. Today we'll close with shapes of orbitals. From Monday the class timings will increase from 5 to 8. Monday there will be class in the evening. Morning we cannot put, evening we can. Completed? Then put the heading as shapes of orbitals. That is another simple topic. Just a short topic. But again you may get a new point here. What is the shape of s orbital? It is. So what does S mean? Not spherical, sharp. S means sharp, but its shape is spherical. What is an orbital? How do you define an orbital? If I ask you what is an orbital, what is your orbital? If you ask me what is my orbital, orbital is a space where electron spends most of its time. That is the definition of orbital. Okay, so if you are in this campus, maybe from 5 to 8, and maybe after 1 month or 2 months, daily 6 hours or 7 hours will be there. So all those 7 hours, where are you spending your most of the time? In classroom. In between breaks, you will be going to corridor. Some will be here, some will be there, some will be there. But wherever your probability is found, I put a dot. You are found at water, put a dot, washroom, put a dot, in the corridor, put a dot, classroom, put a dot. But at most of the time, where are you? I just keep on spotting it. That define your space, that is orbital. So orbital is a space where electron spends most of its time. Okay. Now if I am asking about an s orbital, there is a nucleus, there is an s electron. Where does this s electron spend its time? Then I am just spotting it. At one point it was here, next second it was here, third second it was here. So I am just spotting all of these dots. If I put all these dots together, what shape do I get? Is spherical shape. Okay, that is how I got a spherical shape. So if you look at some physical chemistry textbooks, supposing that this is nucleus, how do they give the shape? Shape of s orbital. All these dots will be very, very, very close. I am just drawing only one orbital, s orbital. For p, d, I cannot draw all these things. You can understand. But as I move away from the nucleus, these dots take space. It means the probability of finding you in the corridor will be less, and away from the corridor is still decreasing. Okay. So when I consider all this shape, the shape that I get is spherical. All these we call it as contour plots. But we don't go for all these things. Simply if I ask what is the shape of s orbital, I say spherical. Completed. In between there is a nucleus. We don't show the nucleus, just draw the s orbital. Then what sign should I give? What sign should I give for an s orbital? No, sign, not charge. 0 is its angular momentum. What sign do I give? You give plus sign. It means everywhere it is like plus only, or everywhere it is like minus only. Okay, or this is like basic plus or minus. Simply you may shade it. That is an s orbital. Okay, that is indication of s orbital. So suppose if I am choosing a wave, the amplitude of that wave at this point is 0. Here it is rising, amplitude is high, becoming 0. Amplitude is becoming negative, becoming positive, becoming negative. Negative, positive is not charge. Above this plus, below this minus. So if it is moving here, it is like all plus, 0, all minus, 0, all plus. So what is an s orbital? S orbital means that electron will have a wave function like this. It means it will be like all plus only. Hope are you getting it? Suppose if this is a line, okay, amplitude line. Now there is a wave which is flowing like this. Then what orbital is this? Plus and minus, plus slope, minus slope. This is a p orbital. S orbital will be like all plus or all minus, all plus or all minus. P orbital, or we indicate it like this. Suppose there is a nucleus here. If this is a wave, the wave will move like this. If one will be plus, one will be minus. Or if it moves like this, if one is plus, one is minus. So if I put p orbital, can I put minus and plus? Yes, it is not every time plus and minus. I can also put minus and plus. So which one are you taking? It is convention. Then I go for d orbital. D orbital, the wave will be like two sides. If the wave is rising, the other two sides the wave will be lowered. So this is d orbital. Now you just take a complete picture of this. Two are going down, minus minus. At the same time, two are going up, plus plus. So this is how the wave moves. This is d orbital. This is p orbital. Okay. So for s orbital, sign is all same. It is either a full plus or full minus. You draw these diagrams. Wherever we come across s orbital, either I put this or I put this or I put this, it is one and the same. In your quantum chemistry point of view, you will define the electron density as probability. You speak about probability of finding an electron in a given space is orbital. Quantum chemistry will be very interesting. So in this universe, everything is not definite. It is like relative. I cannot say you will be in the class. I have to say you may be in the class, because probabilities, you may be outside the class or you may be somewhere else. So that is what probability means. Completed. Shape of s orbital. Later, p orbital. Shape is dumbbell. P orbital. Now when I say dumbbell, I have to define the coordinates. Definitely I have to define the coordinates. For s orbital, where is the electron density? Where is electron density? Or simply let me ask you this question. I am standing here. From this point, what are my degrees of freedom where I can move in this space? How many degrees of freedom are there for me to move in this space? 3 degrees of freedom. How can I move? I can move front or I can move back. This is one position or one movement. I can move towards my right, I can move towards my left. This is second movement. Third movement, I can move up, I can move down. So apart from these three, do you have any other movement? Any other movement? No. If you say diagonal, diagonal is like front and left, or front and right, back and left, back and right. It is combination. But basically you have only 3 ways that you can move in the given space. One is in this direction, second is in this direction, third is in this direction. We call this as 3-dimensional space. So altogether I have 3 dimensions to move in a given space. That we define by spatial coordinates or Cartesian coordinates x, y and z. And by convention, if I am showing the 3 coordinates, I take this as x, just by convention. Okay. Symmetry also we use the same. X towards you and away from you, y towards your right and left, z up and down. These are the spatial coordinates. Okay. Are you able to imagine? This is x, this is y, this is z. If I include any of these 2 coordinates, that become a plane. It means if I am including this z, if I am including this x, both of these will form which plane? XZ plane. These 2 YZ plane. These 2 XY plane. Okay. Now if I just show any coordinate, I'll show it like this. If I have to show any plane, I'll show it like this. You tell me what coordinate or what plane is it? Z. Just say Z, not PZ. Z, X, Y. Now this is plane. XZ plane. XY. YZ. ZX or XZ, anything is same. This is also zx. Either I show it like this or like this, it is just one and the same. Or the walls towards your right and left, what planes are they in? XZ plane. This is in XZ plane, this is also in XZ plane. Wall of the board and the opposite. Board. YZ. The opposite, YZ. Roof, XY. Floor, XY. So this is XY plane. When I show like this, this is XY. Let it be roof or floor, XY. Side walls towards your right and left, XZ. And front and back, YZ. Now you have to imagine electron density present along this axis or in between the axis. That will give you p orbitals and d orbitals. Suppose if the electron density, there is a nucleus in the center. There is an electron density present above and below the nucleus. Which orbital is it? P orbital. This is a p orbital. Which p orbital? Z axis. So which p orbital electron density? Pz. Electron density is moving like this. Px. Electron density is moving like this. Py. Okay. So all the p orbitals, they have electron density along the axis, not in between, they have along the axis. And there are two lobes of this electron density that will give you a dumbbell shape. Okay. So let us come to 3 p orbitals. Hope you understood how you got these px, py, pz. Px means electron density distributed along x direction, y direction, z direction. Px, Py, Pz. I am giving you the conventional axis also. The one pointing towards you, you take it as x, x and minus x away. The one pointing towards your right and left will be y. Above and below will be z. So according to this convention, if I ask you to draw Px, where will you put the two lobes? Px, it means one lobe should be towards you, one lobe should be away from you. But how should I draw it on the board? It is like almost pointing towards you. You have to imagine it is a two-dimensional board. This is x. Py towards your right and left. Pz up and down. And remember one important point here. In the center there is a nucleus. There is a nucleus and there is a nucleus. So if you look at some high standard textbooks, in those high standard textbooks, they never draw the orbital like this. How do they draw the orbital? They draw it like this. Is there a difference? There is a difference. These two lobes, you should not put it like this actually. You are putting it like this means you are putting electron density at the nucleus. That should not come. Therefore, they separate it by putting the lobes like this. It means in the center there is a nucleus. At nucleus there should not be any electron density, nodal plane. So this is how the two lobes are drawn. But even if you draw it like this, it is fine for our understanding. Draw the 3 p orbitals. This is the conventional axis, plus z minus z. The other side we don't give generally. If I give you the other side, this will be below. Plus x is front, minus x is back. Plus y is right. Minus y will be left. above, below, front, back, right, left. In the beginning I asked you two questions. Why is the spin of an electron 1 by 2? Why not it is given as 1, 2, 3, 4, 5 by 2, 3 by 2? Why is it 1 by 2 only? Why the spin is only 1 by 2? Second question, if I give you an orbital, why can orbital accommodate only 2 electrons? Why not a third electron? Finished this one? Just you note down this above, below, right, left, front, back. This will be useful in your symmetry also. The last one, d orbital. What is the shape of d orbital? Double dumbbell. So these are the three different coordinates, x, y and z coordinate. Okay. Now if I am trying to draw, this is z, this will be x, Are you able to understand? Same color, plus plus. If one I take plus plus, other will be like minus minus. I am not writing plus plus symbol, I am shading it yellow. Say if it is plus and plus, this is like minus and minus. Yeah, you tell me which orbital is this? Where is electron distributed? Along z-axis, x-axis. But both, are they including or excluding? They have different signs. Wherever they have different signs, it means there is a nodal plane. Remember, p orbital plus minus, there is a change of sign, meaning there will be a nodal plane. In s orbital, do you have any nodal plane? No, everywhere it is like plus only. But in p orbital you have a 1. In this case there is a difference, nodal plane difference is there. So one will be plus, other will be minus. Whenever you have a nodal plane difference, you have to indicate it by minus. Okay, you are indicating it by minus. So which d orbital is this? This is d z square. Electron density is present along the z orbital. It is subtracting with x. This is dz square y square. This is d x square minus y square. All these are axial orbitals. They are present along the axis. Now let me take one more orbital. Which one should I choose? Yeah. Let me start with dxz. When I say dxz, electron density is present between x and z, not along the x and z, between x and z. This is x, this is z. So that should be present in between. How should I draw? Xz means this plane. Okay, this is the plane. So if you are able to imagine 4 lobes should come in this plane. You are looking it from this side. Then how do you see it? Suppose if this is one plane, this is the other plane, I mean the other side. This is x and z. It means it is in this plane. The orbital will be in this plane. Okay, it is xz plane. Next, if I take yz plane, this is yz plane. So yz means it should be between y and z. This is not along. It has come on white line. Don't think it is along. It is in between. Last one is dxy. So xy means it should be between x and y. Between x and y. X and y will come in this plane. dyz will come in this plane. dxz in this plane. Dx square minus y square will also come in this plane. So dx square minus y square and dxy, they are in same plane. Okay, they are in same plane. But if one is like plus, are you able to imagine plus before you? Just imagine plus symbol before you, dx square minus y square. Multiplication symbol before you, dxy. That is the difference. Both are in same plane. Right? So how many d orbitals did we get? How many? D orbitals, how many? But how many we got? Then which one shall we remove? the combination of dz square minus x square and dz square minus y square is dz square. The combination of these two will give you dz square. So every time for dz square, if you remember in your books also, these lobes will be large. Along z-axis, lobes will be large. If these lobes are small along z-axis, this will be large, because 2 times it is. This is zz, this is also zz. But what is happening to this x and y? It is as small shapes. So here we have a small shape. Here we have a small shape towards you and away from you. 4 small lobes of electron density. But we don't draw those 4 small lobes separately. How do you draw? Simply, we put a circle like. You call it as a donut shape. So if this is plus plus, this will be minus. Okay? So the combination of dz square minus x square and dz square minus y square will give you dz square. So how many orbitals are there altogether? Only 5. dz square, which is a axial orbital, dx square minus y square, axial orbital, because it is present along the axis. These 3 are non-axial orbitals. Got it? You can note it. But while drawing, just keep in sense that suppose if you are drawing dx square minus y square, the 4 lobes are in this plane for your imaginative purpose. I'll just write this dx square minus y square. This is dxz. This is dyz. This is dxy. Yellow color is indicating plus sign, green color is indicating minus sign. You may inverse it also, no problem. Now suddenly I'll ask you one more question. Can you draw dz square plus x square? Can you draw dz square plus x square? Plus, not minus. Is it possible? If you are able to draw dz square minus x square, I am simply asking dz square plus x square. So when are you getting minus? When there is a sign difference. If there is no sign difference, then that will become dz square plus x square. Or if I ask you dz square plus y square, then you have to draw in such a way that there should not be any node between electron density along z-axis and y, or along z-axis and x. How will you draw it? How will you draw it? Anyone? Completed this one? Okay, if I just take the coordinate axis, this is z, this is x. If I ask you dz square plus x square, this is how the orbital will be. All this will be same sign. This will be dz square plus x square. If I ask you dz square plus y square, dz square plus y square, dz square plus y square. Are you able to understand? All will be same sign. No plus minus difference. No plus minus difference. You might have never heard about these orbitals, but they are all linear combinations. They are possible. When you go to group theory, you will come to know symmetry and group theory. At an advanced level of group theory, in the character tables, you will have linear functions, quadratic functions also. In those quadratic functions, if they give you x square, comma y square, comma z square, you will come to know in symmetry and group theory. Simply in the character table, they will give you x square, comma y square, comma z square. What is the meaning of it is the combination, linear combination is allowed. Linear combination means either they may add or they may subtract. If they subtract x square minus y square, that becomes dx square minus y square. If they add dx square plus y square. So dx square plus y square means electron density is present like this. Okay? Or the electron density could be present like this. Or the electron density could be present like this. Completely. Not like 4 lobes. When do you get lobes? When they subtract. When they add, lobes will not come. You just imagine a circle. Are you able to imagine a circular electron density? What is this? Dz square plus x square. This one, dz square plus y square. Dx square plus, sorry, this is x square plus y square. Z square plus y square. Z square plus x square. Okay, all this is your imagination. So altogether how many d orbitals means you have to answer only 5. Don't answer these two because the combination will give you dz square. F orbital shapes are complex, so we don't discuss. Right, so these are the shapes of orbitals. S orbital is spherical, p orbital is dumbbell, d orbital is double dumbbell. And just go through these basics. This will be useful for your future units also. Okay. So Monday the class will be from 5 to 8. Now it is, a session is completed today. Today you may leave.